Welcome to Study Loop.
Okay, our first molecule. And we'll look around here, right? Carbon with 4 bonds, carbon with 4 bonds, carbon with 1, 2, 3, 4 bonds, carbon with 4 bonds, oxygen with 2 bonds, nitrogen with 3 bonds. That's what we expect for all of these elements, right? Hydrogen only having 1 bond in each of these cases. So we're saying carbon needs to have 4 bonds, nitrogen should have 3 bonds, oxygen should have 2 bonds, and hydrogen should have 1 bond. This is what we're checking for in these molecules, like, for example, next. Hydrogen with 1 bond, oxygen with 2 bonds, carbon with 1, 2, 3, 4 bonds, carbon with 1, 2, 3, 4 bonds, and this carbon only has 3 bonds. Now, if it had a lone pair and a negative charge, this would also be allowed, right? Carbon can have 3 bonds, 1 lone pair, and a negative charge, but it cannot be neutral and have only 3 bonds and no lone pairs. So this molecule cannot exist in nature. B cannot exist in nature. Okay, next. Carbon, carbon, nitrogen. Hydrogen has 1 bond, hydrogen has 1 bond, carbon has 1, 2, 3, 4 bonds, carbon has 1, 2, 3, 4 bonds, this carbon has 1, 2, 3, 4 bonds, this nitrogen has 1, 2, 3 bonds, and this carbon has 1, 2, 3, 4 bonds. Excellent. In our next molecule, carbon with 1, 2, 3, 4 bonds, each of these hydrogens with a single bond, oxygen with 2 bonds, carbon with 1, 2, 3, 4 bonds, and nitrogen with 3 bonds. That seems good. And finally, we see carbon with 1, 2, 3, 4 bonds, carbon with, this carbon only has 3 bonds, and it does not have any lone pair or negative charge, right? So this is a problem. Furthermore, this carbon is a problem, and so is this. Right? Typically, we expect to see a similar molecule, but it's necessary for each of these carbons to have a hydrogen. So in fact, we see that E and B are not able to exist in nature.